Hello, class. Right now, we are going to get into Hooke's Law, and there are a few things that we're going to need to know when it comes to Hooke's Law. So let's talk about the theory first. And if I go into Paper by 53, free application, any of you guys can download it. Let me see, do I have anything in here with Hooke's Law? There we go, Hooke's Law. So with Hooke's Law, we basically um, took this scenario, and let me go ahead and get some color here. We took this scenario and we defined this first position right here as the position for equilibrium. And then we defined the first compression length to be right here. Okay? The second compression length is going to be along this line. And then the third compression length will be at this position. So what you will notice is that each one of these will involve a different distance, okay? And we'll need that information. And so we walk through the theory here, and we know that we're going to use the conservation of energy, okay? So we have our kinetic energy, we have our potential energy stored in the spring in the initial condition, and then we have our kinetic energy in the potential energy stored in the spring in the final condition. So we found that when the ball is let's just say position 1, if it's at position 1, position 2, or position 3, at that point the velocity is 0. It's at rest, so the velocity is 0, so that's where we get this. And the only thing we have is our negative 1kx squared in the first click position. And the reason why we have that is because all of the energy is stored inside of the spring. And then once the ball is released, once we pull the trigger, the ball is going to be released, and you'll notice that we'll have a final velocity, and we know this final velocity based on the calculations that we did with the ballistic pendulum. So we also know that the spring will be back in equilibrium, and so at an equilibrium, x is considered 0, so that goes away. So we're going to pretty much use these ideas, and we want to solve for k. So we will know the mass of the ball, we'll know the initial velocity and the displacement. And so we're trying to solve for k because the whole idea is we want to see if k is actually going to be the spring constant for each click, for compression position 1, compression position 2, and compression position 3. So that's what we're trying to verify. So what we found is that our initial position is going to be 36.5 centimeters. The first click position is 33.1, the second click position is 32.0 centimeters, and the third click position is 30.3 centimeters. So we need to find those displacements. The displacement for the first click is coming out to be a negative 3.4 centimeters. And then for the second position, it's coming out to be a negative 4.5 centimeters. And for the third click, it's going to be a negative 6.2 centimeters. So we're going to calculate each one of these constants. K1, case of 1, case of 2, and case of 3 for each one of these positions. And what we're trying to determine is are these coefficients, or these constants, not coefficients, but are these constants the same given some error, okay? And so that's what we're about to calculate. So the first thing that we're going to need our ballistic tool here. And our ballistic tool is going to be, hold on, give me 1 second here. The ballistic tool is right here. Remember, we started off finding our initial velocity this way. So what we did is we duplicated this sheet, okay? You remember we had y, we found our y displacements, we found our average y, we found the initial velocity using conservation of energy, initial velocity using the conservation of momentum, and then we had our initial velocity from our kinematic equations. We found a percent error. It's really not a percent error. It really should be a percent difference. I'm sure I did it that way. Yeah, this is actually the percent difference. And so even though I have percent error, let me make that correction real quick. Percent difference it came out to be less than 10%. So we're going to take this ballistic tool, go over here, and we took like several shots for the video, and I guess I think I deleted all those videos, but you have 3 videos that are associated with this, and you want to track the ball for each one of those compression lengths. So they're going to be 3 shots for each one. So this is the first one, and we found our initial velocity to be 2.90. For the second click position, we found it to be 4.0, and then for our third click position, we found it to be 5.34. Okay, so make sure you take care of those videos and extract this data. And once we do that, we're going to enhance this sheet to actually find we're going to find our spring constant using these velocities, as well as our, and I can just bring this up, as well as our displacements here. So you'll see we have 4.5, 6.2, so we're going to use those. All right.